In this video we will be talking you through using free alternatives to CamDraw and Cam3D, as Cam3D is not available on home computers. We will be showing you this in terms of the conformations of butane and then the conformations of cyclohexane. First, we will open CamDraw. These are the tools available to use. We will just be using this single bond tool. This is butane. If we were using Cam3D, we would copy this and paste it into Cam3D. Now we will do the same thing with MarvinSketch, a free alternative to CamDraw. These are the tools available to us on MarvinSketch. Again, we will just be using this single bond tool. This is butane. This time we will be saving the file with a relevant name to open in MarvinSpace. We will be using MarvinSpace as a free alternative to Cam3D. This is a 3D diagram of butane. If we rotate it, we can see its arrangement in space compared to how it's drawn in 2D. By running this program and clicking OK on the window that opens up, we can see the different conformations of butane. This is the staggered conformation of butane. These two conformations of butane have the same energy. This is because they are the same gauge conformation, before and after the eclipse conformation is formed. The staggered conformation has a lower energy than the two gauge conformations. This is because it is less sterically hindered. We will now do the same thing with the conformations of cyclohexane. As you will see, there are many more conformations. This is cyclohexane. We will now save the file again with a relevant name. We will now open MarvinSpace again. We will now open the file we just saved of the 2D cyclohexane. We will now look at the conformations of cyclohexane like we did with butane. We just click OK on the window that pops up again. This pop-up sometimes appears. Just press OK and ignore it. This is a chair conformation of cyclohexane. It is the most stable conformation along with the alternative chair. The cyclohexane undergoes a ring flip to form an alternative chair. There are intermediates during this transition. These are two intermediate stages and they are both twist boat conformations. They have a higher energy in comparison to the chair conformation. This is another intermediate stage. It is a boat conformation. This has a higher energy due to torsional strain being present between the two central carbons. The twist boat conformations have a slightly lower energy than the boat conformation, due to having less torsional strain, as the carbon atoms are only partially eclipsed. This is the planar conformation. This is what cyclohexane would look like in 3D, as drawn in 2D. This has such a high energy that it plays no part in the conformational analysis of cyclohexane. This is due to torsional strain as all 6 carbon bonds are eclipsed. To summarize, this is why it is important to picture molecules in 3D to understand why they take certain forms and conformations. This is also why programs such as MarvinSketch and MarvinSpace are useful, as they can be applied to a range of compounds.